Okay, chemical reactions of triacylglycerol or TAG. So, triacylglycerol, which is eventually the fats and the oils, reacts like an ester or alkenes because of their because whatever is the functional group for ester and alkenes, yun din yung makikita dun sa triacylglycerol. Recall that ester ester linkage is present in the triacylglycerol between the glycerol and the 3 fatty acid. And alkene is present in the carbon to carbon double bond present in the fatty acids. Okay? So we have two functional group present in a triacylglycerol. Esters, all triacylglycerol has this one, ester linkage. And alkenes, if and only if the fatty acids attached to the triacylglycerol has double bonds. Or if the fatty acids in the triacylglycerol are classified as monounsaturated or unsaturated fatty acid, then that will be present. But if that is saturated, of course, there is no alkene or there's no double bond present. Okay, so we have um, chemical reactions. I think there's 4 chemical reactions that we're going to discuss under the reactions of triacylglycerol. Okay, so the first one is hydrolysis. Okay, so hydrolysis is just the reverse of esterification. So kabaligtaran lang siya. Remember that esterification is the process wherein you produce the triacylglycerol from the reaction of glycerol and 3 fatty acid. So ang kabaligtaran lang niyan ng esterification ay hydrolysis. When we say hydrolysis, you need water molecules. For this type, you need particularly 3 water molecules. Okay, so that each of these water molecules will interact with the ester linkage that is present in the triacylglycerol. And after hydrolysis, okay, you're going to break the 3 ester linkage, thus you are producing 4 products. And what are those products? The glycerol and the 3 fatty acid, which is originally the starting point or the starting material for esterification. So, kabaligtaran lang niya. Okay? So, for a complete hydrolysis, so you're going to produce glycerol and 3 fatty acid made mention a while ago. But for partial hydrolysis, which is common for digestion, okay, you are producing a monoacylglycerol and a 2 fatty acid. Ibig sabihin, for partial hydrolysis, hindi lahat ng ester linkage ay mabibreak. Rather, dalawa lang ang mabibreak, hindi yung tatlong ester linkage. That's why meron tayong monoacyl. Remember that the triacylglycerol, the tri indicates that there are 3 ester linkages. But for partial hydrolysis, since we are only breaking some of its ester linkage, so one of the product is monoacylglycerol. And of course, the 2 fatty acid molecules pa rin. Okay, so to understand it better, let's have this equation or chemical equation. So we have here complete hydrolysis of triacylglycerol. So this is the triacylglycerol. And eventually, we need water to be added so that the ester linkages between the alcohol part and the acid part of that triacylglycerol will be broken. So the mechanism is you're going to add the hydrogen molecule of water to the glycerol part. So, dito sa O na yan. That's why we have it here. Makokompleto natin si glycerol. And the hydroxyl part of that water will be added to the acid part, which is the fatty acid. So, dito sa carbonyl group, mai-add itong hydroxyl group. So, magiging ganito. Okay. So, for complete hydrolysis, okay, the triacylglycerol with the reaction of 3 water molecules will produce the original glycerol and the original 3 fatty acids that was the building block of this triacylglycerol. Okay, so ito na yung mga water molecules that was added. Okay, So remember, for complete hydrolysis, we are producing four products, one glycerol and the three fatty acids. Okay. Since the identity of the triacylglycerol here in the reaction is a mixed triacylglycerol, ibig sabihin, magkakaiba yung fatty acids niya. So therefore, we are producing three different fatty acids. Okay? Now, for partial hydrolysis, which is common for digestion, okay, so we only be using two water molecules that will break the first and the last ester linkage on this triacylglycerol. So the middle part will remain and hindi siya mabibreak. Okay, so it will remain the same. So this one is only the site of reaction. Dito lang naidagdag yung hydrogen part ng water. So therefore, this fatty acid will be separated from the glycerol. So ito rin na-separate siya kasi na-break yung ester linkage. Okay. With this, we are producing three products during partial hydrolysis. So one is the monoacylglycerol. Monoacyl kasi iisa na lang yung acyl group niya. Okay? Isa lang yung naiwan. And the two fatty acid that was separated from the triacylglycerol. Okay? So that's the difference between partial and complete hydrolysis. And of course, since a while back sabi natin na sa digestion nangyayari ito, there are of course certain enzymes that will help the reaction. Okay? And we have saponification. Saponification involves two steps. So we have hydrolysis, ito yung sinabi natin kanina, wherein the triacylglycerol reacts with three water molecules wherein the glycerol and a three fatty acid will be produced. So that's the first step. And then the second step is the acid-base reaction wherein these three fatty acids will now be used and will be reacting with the base in the form of a metal hydroxide, particularly here is the sodium hydroxide, at makakaproduce daw siya ng three fatty acid salts. So may salts na dyan and water molecule. So if ito alam na natin to hydrolysis. Meron na tayo na produce na 3 fatty acid. Ito yung mga yon. Okay, so ito na yung 3 fatty acid molecules. So after hydrolysis, these 3 fatty acids in saponification will undergo acid-base reaction. So take for example, ito yung isang fatty acid na na-produce. Makiki-interact daw siya sa sodium hydroxide. Okay, so since we are producing 3 fatty acid during hydrolysis, of course, we will be needing 3 molecules of sodium hydroxide. But for this example, okay, so isa lang yung gagamitin mo, i-represent natin na fatty acid. So isa lang na sodium hydroxide muna ang gagamitin natin. Okay, so the mechanism here is the hydrogen coming from the fatty acid and the hydroxide group coming from the base or from the sodium hydroxide will interact together to form water. And from that, the hydrogen, okay, will be replaced by the sodium. So kaya ayan. Okay? So once natanggal yung hydrogen doon, magiging negative part na to ng ating fatty acid, and then we're going to have the sodium ion or the metal ion to be attached there. Okay, so as looking at the structure of the fatty acid salt, meron siyang positive charge and negative charge part. Okay, and by definition, when we say saponification, this is actually the term they use as the process by which the soap was made in earlier times. Okay, so paano ba nagagawa yung soap? They're going to heat the lard, which we all know galing yan sa animals, and then they're going to react it with lye. And the lye is eventually present in the ashes of wood or an impure form of potassium hydroxide. But today, hindi na ganun ang paggawa ng soap. Rather, they are going to hydrolyze the fat or the oils using a high pressure and high temperature and a chemical known as sodium carbonate as a base. Okay, so nevertheless, soap are still carboxylic carboxylic acid salts. Okay, so remember that the fatty acid is a carboxyl group, carboxylic acid rin. Okay, and it has a salt in a salt form. Okay, so the carboxylic acid salts, known as soap, and the detergents as sulfonic acid salt, both contain a very small portion of positive ion in the form of sodium or potassium. So ito yon. Yan yung part na yan. It could be sodium or it could be potassium ion. Okay? And the negative ion contains the very long chain of carbon atoms. So ito yung sinasabi ko kanina. Ito yung negative part and yung metal ang positive part. Now, the negative ion is the active ingredient. Active ingredient siya. And the cleansing action of the soap and detergent is due to the dual polarity that the carboxylate of the soap or the sulfonate ions of the detergent. Okay, so the long chain is called the tail, and which is nonpolar, and the small, sorry, so this is the tail. Ito daw yung tail. Yun yung tail. Kasi mahaba siya. Tail. Mahabang carbon atom. Okay? So that's the tail, and that's the nonpolar part. And of course, the head is the polar part. The small portion here for the metal is the polar part. Now, because of this dual polarity, polar and nonpolar portion of the carboxylic acid salt or fatty acid salt, okay, so this one, the nonpolar part or the nonpolar tail of the soap could actually interact with the nonpolar greases. Kasi nga, polar, in order for them to attract each other, there should be the same polarity. So, nonpolar tail will interact with the nonpolar grease na nasa mga damit natin, yung mga dumi sa mga damit na nilalabhan. And then we have the polar head, which reacts or interacts with water. Okay, so with this structure of the fatty acid salt or for the soap, micelle formation is possible. Pag sinabi nating micelle, it is a spherical cluster of molecules in which the polar portion, ito daw yung polar portion here, is on the surface, and the non-polar portion, which is the tail, is on the interior, carrying the grease. Okay? So, kaya na-isolate yung mga, or natatanggal yung mga dumi sa mga nilalabhan, sa mga labada. It's because the this head and tail, or the polar and non-polar portion of the fatty acid, actually traps the grease inside. So, ayan, grease. Okay, so micelle do not combine into a larger drop because of their surfaces are all negatively charged. Okay, so this is the whole micelle, fatty acid micelle. At nandun daw sa loob yung grease. So this is how the cleaning action of soaps or detergent works. Okay, so that's for saponification. Then we have hydrogenation. When say hydrogenation, this is just a reaction with hydrogen. Now, ang mechanism is once hydrogen is added, the site of reaction is actually the carbon-to-carbon double bond. If you could still remember, yung hydrolysis kanina, ang site of reaction natin is the ester linkage. But for hydrogenation, the site of reaction here are the double bonds. Okay. Thus, since the addition of hydrogen will be added to the double bond, the saturation will increase after the reaction. Okay. Paano ang ibig sabihin ng saturation will increase? Mabe-break na yung unsaturated part and it will turn into a saturated part. Pag sinabi nating unsaturated, yung site of double bond yan. Pag sinabi nating saturated, of course, all carbon-to-carbon bonds will be single bond. Okay? So, for hydrogenation, always bear in mind, you are starting with the triacylglycerol. Okay. After hydrogenation, still, isa pa lang din ang product ninyo. Iisa lang din ang product ng hydrogenation. Kanya lang, ang identity na lang ng mga fatty acids attached in the glycerol part will be different. So, kung kanina, yung ating triacylglycerol has 18-1, 18-1, or 18-1, ng mga fatty acids with the use of 3 hydrogen molecules, ito, 3 hydrogen molecules, na break siya. So, magiging 18-0 na lang. Okay? Ang mechanism kasi ng hydrogenation, okay, originally, if that is the double bond and that is the site of reaction, okay, so, syempre, this carbon atom, originally, may hydrogen siya dyan. Or rather, merong naka-attach siya sa other carbon atom. Okay? Ito, meron siyang other carbon here and 1 hydrogen. Okay? So, for every double bond, what happens here is that magbe-break ang double bond at magiging single bond. Okay? So, pag yan ang nangyari, if that's the case, so the double bond will be broken and it will turn into single bond. Okay. So pag nag-turn ng single bond na yan, kulang na yung 4-bond requirement niya kasi natanggal na yung isang bond dun sa double bond. And that is the way for this hydrogen to be added. So kailangan daw ng 2 molecule ng hydrogen. Okay? So bakit 3 hydrogen ang kailangan here? Okay, so we need 3 hydrogen molecules. Okay, so we have here hydrogen. We will be using 3 hydrogen molecules because we have 3 double bonds. Of course, kung dalawa lang yung double bond dyan, then therefore 2 hydrogen molecules lang ang kailangan natin. Okay? Always bear in mind that for every double bond, it needs 1 hydrogen molecule. And when I say 1 hydrogen molecules, we are referring to a diatomic atom of hydrogen, H2, pag sinabing hydrogen molecules. Okay? Ulitin natin, for hydrogenation, hindi nagbe-break ang ester linkage, rather, ang site of reaction lang ay yung mga double bond. At nagiging single bond siya. Okay? Now, we also have the reaction called as partial hydrogenation, wherein some, not all, of the double bond present are converted into single bond. With this, the liquid, usually in plant oils, are converted into semi-solid material. Okay. Remember, if we could still recall, the lard or the fats wherein it prevalent sa kanya ay saturated fatty acids usually exist as solids at room temperature. Okay. Now, if we know that meron siyang unsaturated, of course, this could probably exist as liquid kasi mas lower ang melting point ng may unsaturated part. So, once some of the double bond is not converted into single bond at nag-retain siya na double bond siya, they are going to produce or be converted into a semi-solid material. So, this process or this partial hydrogenation is actually used for the solid cooking shortenings, stick margarine. So we all know that semi-solid itong mga to. Produced from liquid plant oils, and of course the short spread margarines are also product of partial hydrogenation. So they are all semi-solid materials. However, okay, may concern tayo tungkol dito sa mga partial hydrogenated materials na to, particularly the vegetable oil. Meron mga concern. And it is about the conversion of the cis double bond fatty acids into trans double bond. When we say cis, okay, cis double bond, yung groups daw dyan sa double bond na yan, say for example, you have hydrogen here and hydrogen, and other R represents other series of carbon atom. This is a cis double bond, wherein the hydrogen groups are on the same side. Parehas silang nasa taas. It's either parehas na nasa taas or parehas na nasa baba nitong double bond na to. Now, the issue with the partial hydrogenation, the cis double bond that is present, which is supposed to be a good fat or a good fat, okay, matuturn daw siya into trans double bond. Ang itsura ng trans double bond, we have here, site pa rin natin ay double bond, carbon to carbon double bond. Okay? Ang nangyayari kasi for trans, okay, the hydrogen group will now be pointing to opposite direction. Okay, so still meron din tayong R group dyan. We all know that R, naaral natin sa organic, is the series of carbon atom. Okay. For cis, ulitin natin, it could either be the hydrogen, both hydrogen are on the top or same bottom. Basta same side sila. For trans, magkaiba. Yung isa nasa taas, yung isa nasa baba. Okay. And with this trans double bond, okay, ang effect daw niya ay similar to saturated fatty acids. And we all know that saturated fatty acid is known as the bad fat. Okay, or it could increase the risk for the occurrence of heart disease. Okay, now, pagdating sa naturally trans fat, which is actually found in meat and dairy products, this only constitute 15 to 20% of the dietary trans fatty acid intake. And we have to take note that this is not the cause of any health problem because these are naturally occurring. The remaining 80 to 85% of the dietary trans fatty acid was actually obtained from the commercially produced trans fatty acids, and it is through the partial hydrogenation process. So ito yung nakaka-cause ng health problem. Yung mga dietary intakes natin which are commercially produced via partial hydrogenation process. And we all know that ano yung mga na-produce, sabi natin kanina dito, yan, mga margarines. Okay? So, meron mga soft spreads. Okay? Or anything that was produced via partial hydrogenation. Okay? Before, the only way that the consumer could identify that there is a trans fat was to look for the word hydrogenated on the list of ingredients. Okay. However, in 2016, the Food and Drugs Authority required that the trans fat content of the food be included in the nutrition fact label or panel. So makikita na natin dun sa mga nutrition facts label, dun sa mga lalagyan or supot ng mga pagkain natin, meron na tayong corner doon or meron ng isang item doon, trans fat. Kasi required na yan na kailangan i-declare nila kung meron trans fat yung food na ginawa nila. Okay? However, we have to take note of this one. The zero trans fat per serving does not necessarily mean that it is a trans fat free. Hindi ibig sabihin na pag sinabing zero trans fat, walang-wala ng trans fat na yon. Kasi the FDA regulations allow that the trans fat level of less than, take note less than 0.5 grams per serving can be labeled as 0 grams per serving. So, kapag dun sa food label natin, nutrition facts, sa mga packages ng ating mga food, nakalagay na trans fat ay 0 grams, it does not represent that is 0 talaga, na wala talaga. Rather, pwede din na meron siyang less than 0.5 grams. Kasi allowed naman daw yan. Okay? Okay. Now, the last reaction is oxidation. When we say oxidation, of course, this is a reaction with air. The reaction of fatty acid with oxygen, with oxygen, and which is eventually found in air. Okay, so the mechanism is the carbon-to-carbon double bond present in the fatty acid residues of the triacylglycerol are subjected to oxidation with the molecular oxygen. Pag sinabing molecular oxygen, so yan, O2, which is present in the air. And that oxygen is the oxidizing agent. Okay, so ang mechanism, mabe-break daw yung carbon-to-carbon double bond and maproproduce ang aldehyde and further carboxylic acid part. So the mechanism is the site of reaction would be the double bond. Magbe-break daw yung bond na yan. So magproproduce tayo ng dalawang carbon atom. And dyan madadagdag yung oxygen. Okay, so instead na double bond siya, naging carbonyl group siya. And we all know that carbonyl group is the functional group for aldehyde. And further oxidation will cause for this carbonyl group to be oxidize in a carboxyl group, which is eventually the functional group for carboxylic acid. Okay, and still they are in short chain, short chain. And with that oxidation, these short chain aldehydes and short chain carboxylic acid that was present, or rather that is the product of oxidation, is actually the objectionable odor that could be identified in the fat and oil. At kapag medyo objectionable na, iba na ang amoy ng mga fats and oils, sasabi natin that they are rancid. Maanta. Maanta sa Tagalog. Rancid. It's rancid already. Okay? So, na-oxidize na siya. Okay? And to prevent such unwanted oxidation, meron naman tayong dinadagdag para sa ating prepared foods at ang tawag natin dyan ay antioxidants. We added these antioxidants to foods so that oxidation will be prevented. Pag sinabi nating antioxidants, these are the compounds that are readily or more easily oxidized than food. So, they prevent, prevent oxidation to happen in the food they are preventing, or yung kung saan sila in-apply. Pero it does not mean na hindi sila na-oxidize. Actually, yung antioxidant, sila ang easily oxidized. Sila ang na-oxidize rather than yung prepared food kung saan sila dinagdag. Okay, so with that, dahil sila ang na-oxidize, na-protect nila yung food. Instead na yung food ang ma-oxidize, sila yung na-oxidized. Okay? And there are two naturally occurring antioxidants. These are vitamin C and vitamin E. And the synthetic oxidation inhibitors are BHA, or butylated hydroxyanisole, and BHT, which is butylated hydroxytoluene. Okay? So these are being added para hindi daw mag-undergo ang mga foods and in oxidation. Okay, so again, we have 4 reactions for triacylglycerol. Number 1 is hydrolysis, then saponification, and then we have hydrogenation, and the last is oxidation.